Good morning, one and all. Today we are going to solve the economic load dispatch by using the participation factor method. Already in our previous classes, we have discussed detail about the base point factor method and participation factor method. So that video I will give in the description. That also, once you go through before solving this problem, if you not understand this problem, uh, then you need to go through the theory, then you just come back to this problem, then it will be very easy for you to solve. Take down this problem. Consider the following three units. Here directly IC1 is given. IC1 is equal to 7.92 plus 0.003124 PG1. IC2 is equal to 7.85 plus 0.00388 PG2. Next, IC3 is equal to 7.97 plus 0.00964 PG3. Demand is given as 850 megawatt and PG1 given as 392.2 megawatt. PG2 given as 334.6 megawatt. PG3 is equal to 122.2 megawatt. Determine the optimum schedule if the load is increased to 900 megawatt by using the participation factor method. So here in this problem, you need to clearly see whatever the problem is given, what is the method they have given to solve this problem. So somebody, what they will do is blindly they will solve without seeing this participation factor method. They will take PD, power demand, as 900 megawatt. Simply they will solve and they will get some answer, and they will compare this answer, and they will compare, and they will just close this problem. Just they will write some conclusion. They will just wind up this problem. So don't do that. Clearly, they have given the in the data itself. They are given as solved by using the participation factor method. So solution, the new values of generation are given by new values are given generation are calculated by PGI new is equal to PGI base plus del PGI divided by del PD into del PD. This also already we derived in our previous classes. That already I said I will give that video in the description. Just watch this video, watch that video, then come and solve this problem. This is the formula we already derived. That is PGI new is equal to PGI base plus del PGI divided by del PD the whole into del PD. Now we need to calculate PG1 new. PG1 new is equal to PG1 base plus del PG1 divided by del PD into del PD. So here this we need to calculate. That is del PG1 divided by del PD. This also already derived. 1 divided by, that is del PG1 divided by del PD is equal to 1 divided by F1 double dash, the whole divided by 1 divided by F1 double dash plus 1 divided by F2 double dash plus 1 divided by F3 double dash. F1 double dash we need to calculate. Already given in the problem what IC1 is given. IC1 is nothing but F1 dash. They will give like confusing. Sometimes they will give like a IF1. Okay, IF1, IC1, and D. Sometimes they will give DF1 divided by DP1. DPG1. That also same. That is nothing but F1 dash. So whatever is given, you need to just like you need to able to identify which is F1 dash, which is F1 double dash, like that. Sometimes directly they might be given F1 double dash like that. So you need to see. So incremental cost of one, incremental cost one, IC1 is nothing but F1 dash. F1 dash is given. So F1 double dash means what? You need to differentiate again with respect to PG1. If you differentiate again with respect to PG1, this will becomes 0. This becomes 1. So this alone, this answer only will come. If you differentiate with respect to DPG1 for first F1 dash, you'll get 0.003124. Just yeah. We get the answer as 0.003124. That is F1 double dash as 0.003124. Similarly, F2 double dash. F2 double dash, if you differentiate with respect to DPG 2, so this will become 0. This term alone will come. This will becomes 1 into 1. So 0.00388 only will come. So directly you can write. Next, F3 double dash is equal to. Similarly, we need to differentiate with respect to PG3. PG3, if you differentiate, so this becomes 0, this into 1. So this will come like 0.00964. Here 0.00964. Now you need to substitute all this F1 double dash, F2 double dash, and F3 double dash here. So if you just substitute, you'll get the answer as 0.4693. That is del PG1 divided by del PD. You just tell in the comment whether you are getting the same answer or not. Just substitute in this equation. That is PG1 new. PG1 new is equal to PG1 base. PG1 new is equal to PG1 base. PG1 base what? Already given in the problem. That is old value. Base value or old value. Some books, if you see, it will be the old PG1 old. They will be mentioned as PG1 old. So old value or base value, whatever given in the problem is 392.2 megawatt. Just you need to substitute here. This we already calculated, and this change del PD is nothing but change in the power demand. How to calculate the change in the power demand? Here, optimum determine the optimum schedule if the load is increased to 900 megawatt. Increased to 900 megawatt. So power demand already given as 850 megawatt, but the load is increased to 900 megawatt. So what you need to do is simply you need to minus this. That is 900 minus 850. That is 50. That is del PD is nothing but 50 megawatt. Just you need to substitute here. So this is what I said no. Yeah. Here I said no. Here, yeah. Del PD is nothing but 900 minus 850. That is nothing but 50 megawatt. Just you need to substitute all the values, whatever I said. That is PG1 new is equal to PG1 base plus del PG1 divided by del PD. That value already we calculated into del PD. So that you need to substitute, simplify it. We are getting the answer as 415.665 megawatt. So you just tell in the comment whether you are getting the same answer or similarly you need to calculate PG2 new. PG2 new is equal to PG2 base plus del PG2 divided by del PD into del PD. Next, this you can easily calculate. That is del PG2 divided by del PD. This already general formulation is there. That is, if it is 2 means 1 divided by F22 dash divided by 1 divided by F1 double dash plus 1 divided by F2 double dash 1 divided by F3 double dash. Already we calculated all these things. Just to substitute it, simplify it, we are getting the answer as 0.3781 after decimal 4 digits. Don't round it off. Del PG2 divided by del PD, we are getting this 0.3781. Similarly, we need to calculate PG2 new. PG2 new is equal to PG2 old plus this value, that is del PG2 divided by del PD into del PD. That is change in the power demand. Change in the power demand 50 for all three generating units because it is changing from 900 megawatt to 850 to 900. So difference is 50. So yeah, that we are taking there. Simplifying, we are getting the answer as 353.5072 megawatt. Similarly, PG3 new. PG3 new is equal to PG3 base plus del PG3 divided by del PD into del PD. Just you need to calculate del PG3 divided by del PD. Del PG3 divided by del PD is equal to 1 divided by F33 double dash the whole divided by 1 divided by F1 double dash plus 1 divided by F2 double dash plus 1 divided by F3 double dash. So just we already calculated all these things. Just substitute it, simplify it. We are getting the answer as 0.1521. So the next del PG3 new is equal to del PG3 base value already given in the problem. That is 122.2 megawatt plus this value, that is del PG3 divided by del PD, that you need to into del PD. Del PD is 50 megawatts. Just you need to substitute, simplify it. We are getting the answer as 129.805 megawatt. Don't simply stop up to here. You need to take out all the answers. You need to write the conclusion clearly. Then only full marks will be awarded. So suppose this kind of problem, they will be asking in your 5-mark question. Okay, because it is very simple. Next, the optimum generation schedule for generating units when the load is increased from 850 megawatt to 900 megawatt is PG1 is equal to 415.665 megawatt. Already we calculated. Similarly, you need to write all. PG2 is equal to 353.5072 megawatt. PG3 is equal to 129.805 megawatt. Also, these generating units satisfying the power demand of 900 megawatt. If you add all these things, we are approximately getting like 8099.99 something we are getting. And you just tell in the comment whether you are getting the same answer or not. So you need to write the conclusion clearly. Then only full marks out of 5 marks, full marks will be given. If you stop up to this, they will be giving only 4 marks only. Somebody what they will do in emergency, they will like for time being they will solve and they will stop up to here. They will not write the conclusion. So 1 mark will be reduced if you not writing this conclusion. This is how you need to solve the problem for economic load dispatch with the participation by using the participation factor method. Okay, this already clearly we derived in our previous classes that I will give you in the description. So you can easily understand this problem and you can get full marks. You need to get full marks. The problem is that don't skip this problem. It's a very simple problem, just a formula substitution answer. That's all. Very simple problem with your scientific calculator. But the scientific calculator, you need to use it properly, use it optimize. You need to use in an optimized way so that and also your fingers has to play in your scientific calculator. Then only time will be sufficient. If you do slowly, you just add, multiply, write, do the calculation like that, then it will eat your time in your exams. Okay, thank you, everyone.